Oh, my heart stopped.
In a previous video, we built the frame of my new dream desk, with the standout feature being a central dashboard interface. But before we can add knobs, switches, and buttons, we're gonna add lighting like you've never seen before.
I love the blue. I'm so happy. Mate, I'm so excited. Shing! 5 meters of addressable RGB LEDs.
So I pulled out the cables and I added some tape so they don't accidentally like touch and short circuit. Oh yes! How sick is that? Look at this, this is bright. Okay, at the moment they're all doing the same color, but every LED is addressable. You can change the color of each individual LED. Yes, look at this. Imagine the whole desk. So the prototype process was quite simple. I just tried out some different layout ideas and I settled on a single strip shining away from my eyes. Not only will the aluminium frame reflect some of the light inside, but I also don't have to stare at the individual LEDs. But I do have to be careful for scratches on the acrylic surface because being backlit, they'll now stand out like crazy. I also used some spare strips with some white material under the desk, and this created like a lightbox effect, so I cannot wait to see the whole desk lit up. The brains of the operation is this, Razer Chroma addressable RGB controller. It's intended to go on a desktop PC to control fans, water coolers, and LED strips. So because it's made for desktop PCs, the back of the box will say it needs a power supply with a free Molex socket and a motherboard with a free 9-pin USB header. Dude, I'm rocking a laptop. I've got nowhere to plug these cables. Well, the Molex connector goes to a DC power plug and the motherboard USB header to micro USB. That means I can take a DC power supply, plug it in, and a micro USB cable and plug that into my laptop. Yeah, boy.
Oh, this is gonna look so good once it's lit up. So now I've got to measure up the cable runs so I can go buy the wiring to then connect it all together.
Mate, you could win prizes from today's sponsor PCBWay in their 6th project design contest. Simply submit your electronics project or mechanical design to potentially win some really cool prizes. And get this, you get a Raspberry Pi Pico just for participating. Entries are open now until the 15th of Jan 2024. Click the link in the description below to enter. I want to see you win that $1,500 cash prize.
No welding. How good is this stuff? Oh no, we might have a problem. This is one thick boy.
At the end of part 1, I showed how easy it was to slide an LED strip into a piece of the desk. But this LED strip is slightly thicker than all of the other LED strips I tested. I even tried some electronic safe lube and it still got stuck.
Mate, it should be just a straight slip and slide. So the plan now is to take the strip and like slot it. I'm hoping that when this bounces off the board, it's gonna work out. This isn't going to plan. So I wanna cut up some core flute, it's huge. Put the front section back together and do some tests to see if the LEDs look best on top or on bottom. Oh, that is much nicer. Up here, it's easier to see, but down here, there's more blurring. Sticky tape it up. It should cover us for a quick test. All right.
Now in this test, the LEDs are pointing downwards. Instead of using my eyes, I'm gonna use false color on my camera, and this allows me to see the banding and how even the light is distributed. So now I can move the strip to point upwards. I can see each individual diode a lot more. Plus we can see this like a red band where part of the green or blue chip must be covered by the aluminium. So angled down, this is just completely clean.
Oh man, it's so easy to get disheartened when things aren't going as planned, but this looks incredible. Norman, what do you think? Bro, how good is this?
So for wiring power, it's pretty straightforward. I'm gonna do the shortest run possible to each LED strip segment. But for data, I'm actually over the limit of how many LEDs can be connected to this controller. Each port can talk to 80 LEDs, but the total of all 6 ports can't exceed 240. Now the strips that I used for prototyping were 30 LEDs per meter. 5 meters worth is only 150 LEDs total. However, the more LEDs you have per meter, the smoother animations are going to be. So I opted for 60 LEDs per meter strips. The longest run on the desk is about 1.2 meters using 72 LEDs. So that's under the 80 per port limit. Nice. But I need 5 meters worth to cover the inside of the desk and across the back shining onto the wall, totaling 300 LEDs. Now that is over our 240 limit. Thankfully though, in my research, I found you can split the data from 1 port into 2 strips and they'll run in parallel doing the same animation and the controller will think it's only talking to 1 strip. This let me break the desk up into 4 zones. So I've got 3 copying each other going front to back and the 4th is the dashboard hub. Each port sees under 80 LEDs and from the 300 total, it only sees 170. How cool is that? Somehow, this all just got more complicated. Razer won't pick up a second power supply. The power supply is hooked up directly to the strip. We've got a shared ground to the Razer box and just data coming from Razer. Now watch this, if I hit detect, it lights up the whole strip and then goes, oh no, I didn't find anything, mate. Sorry, there's nothing connected. Oh, I'm sorry. I'm pretty sure that's Razer green. So why am I trying to use separate power supplies? Well, the manual of the Razer controller states that it can only supply 45 watts. And this LED strip is meant to consume up to 18 watts per meter, and with 5 meters of LEDs, that's 90 watts. And so I purchased two 5 volt 12 amp power supplies, each giving us 60 watts of power, and so that the 120 watts total covers the potential 90 watts of the strip. Thankfully, I remembered reading on Reddit that if you power a single LED directly from the Razer controller, you can then manually type in how many LEDs are on the actual strip to get it to work. And so this meant I had to create 4 of these wacky cables that have a single LED chip powered by the Razer controller, and then a data and shared ground cable for the actual strips. If I'm being completely honest, making each strip sucked. Mainly because I had to manually crimp these connectors for the Razer controller. So I went through and raided my supplies of spare cables and old projects, and I found that jumper leads or DuPont connections fit perfectly to the Razer controller. The problem is that I cheaped out on buying the specific crimp tool, and manually doing it with pliers had to make it over 10 times longer with every data connection.
It's a tendency of mine to completely underestimate the amount of time a project will take. This is one of them. To know if this will work, I should be able to make the first 2 diodes a separate color to the rest of the strips. Oh, it works! Yes, let's go! What I'm stoked about is that I was able to splice midway into a strip and split that data parallel to another strip. This means I can send data to certain segments that didn't start at the same point as the rest of the strips connected to a port. To confirm that the 18 gauge wire that I was using was sufficient for this project, I took some current draw readings at max brightness Y, and it turns out that they're only drawing 10 watts per meter and not 18 watts, meaning that I could have scraped by with just one power supply, but it's best to have some headroom anyway, so I'm still gonna have one power the front of the desk and one power the back. I'm also gonna split the load through fuses to better protect from short circuits. So data for zone 1, zone 2, zone 3, zone 4. Let's light it up. Power for front circuit, power for our rear circuit. Data. Oh. Yep. Okay, it's only saying there's only one LED. So port 2, what's zone 2? Let's trace the wire. Zone 2 is the right hand side, which has 25 for zone 2. Port 3. About 54, 21, 22. I've entered in all the LED numbers. I've rearranged all the LEDs. Time has come. Select all pixels. Done. What happened? Oh, set them all to like no color. Oh my God, my heart stopped. Oh man, I thought it just broke. I'm so happy. Max brightness is absolute insanity. Now, the main reason I went for the Razer controller is because I can sync the entire desk with my health status and special abilities in games. So if you want to see what that looks like, let me know in the comments below whilst we wait for the dashboard parts to arrive. You probably can't even see the dashboard, the whole thing's just blown out. It's insane.